My name is Dr. P.C.Patel, Professor and Chief Soil Health Specialist, Anand Agriculture University and Paru University, Mati Mati Agromart Private Limited, Anand, Gujarat. So today the topic of my YouTube is how to manage alkali soil, or it is also known as sodic soil. So you can see in India, the salt affected soil black color change so indicate the salt affected soil. So in Gujarat and Uttar Pradesh and Punjab and some parts of the Tamil Nadu, Andhra Pradesh, West Bengal. So you can see this Rajasthan. So black dots indicate the salt affected soil. So it may be saline or sodic or alkali soil. So alkali soil also known as solunades or sodic soil. Saline soil, sodic soil, saline soil are those that have pH of saturated phase is greater than 8.2 and ESP greater than 15. So you can see here this sodic or alkali soil, and the crop productivity of that soil is very, very low. How to fix sodic soil? So soil testing is required for identify soil problem, measure soil pH, electric conductivity, other related parameters. For the most accurate analysis and the soil samples, so reputed soil testing laboratories like Sevam Agri Clinic and Agri Laboratory, Bhavnagar, Gujarat, India. So in this laboratory, I am working as a chief soil health specialist. So our helpline number +9163595959. So salt affected soil. So in India, the salt affected soils more in Uttar Pradesh 1.295 lakhs hectares, whereas second number is in Gujarat 1.214 lakh hectare. Then in Rajasthan 1.122 lakh hectare, whereas in Andhra Pradesh 1830,000 hectare, and it is reported by the Central Soil Research Institute, Karnal, Yagi, NK. So crop productivity, I told there the crop productivity of that soil is low. So sodic soil from agriculture standpoint is that contains sufficient exchangeable sodium to adversely affect the growth of most crop plants. The productivity of sodic soil limited mainly because of the deterioration in their physical properties, which cause over aeration, restrict root development, and enhance root diseases. So plant become weak, and there will be a problem of the root diseases because there is a poor aeration, waterlogged condition in sodic soil. So aeration is poor, so the root disease is observed. So causes of poor productivity of soil: high content of sodium ion, exchangeable, coupled with high pH, have a toxic action on root and roots are damaged. Under extreme cause, the roots and the soil organic matter present in soil get dissolved. So dispersed condition, the soil structure is deteriorated due to sodium clay particle. Poor aeration is another important cause of poor productivity of soil. Root cannot get sufficient oxygen from soil atmosphere. Carbon dioxide of soil atmosphere is very high and oxygen is low. So root cannot respire and resulted in poor productivity. So root is the poor, then the uptake of the nutrient is also poor. So the crop growth remains poor and we are getting low crop production. Deflocculation or dispersion and swelling of clay due to high exchangeable sodium. So exchangeable sodium percentage greater than 15, sodium absorption ratio is also more than 15. So this causes the teleoperation very difficult, so cause the poor productivity. So how to improve alkaline soil. So chemical methods, use of gypsum, use of sulfur, then cultural method, mechanical method. So built an embankment to check the tide, land leveling and contour dams, establishment of drainage, network drainage is required to drain the excess water from the field, cracking of the pan in the subsurface layer through the hole boring auger. Then hydrological, salt flushing, salt leaking, water withdrawal. Then physical method, corrosion of salt layer, deep tillage, subsoiling, profile reversal, up and down of the profile. Use of soil conditioner, sand, tank as compost and synthetic polymer like PVPC. Then fifth one is the biological method. So use of fertilizers, green manure like denture, sonam, water, acinate, planting of salt tolerant crop for partially reclaimed soil. So normal crop cannot be grown, but we should have to grow the salt tolerant crop like cotton, sorghum, then barley, cotton, etc. So management strategy. So bulky organic manure, green manure, crop residues, and the biological material which produce weak organic acid help in create temporary acid condition help in reclamation. So it reduces soil pH. High content of sodium ion exchangeable coupled with high pH have a toxic action on root and roots are damaged and the same cases the roots and the soil and organic matter in the soil get dissolved. Leaching with good quality water, a good crop rotation is excellent. Frequent irrigation with small quantity of water is the successful irrigation management practice. Sometimes permeable soil can be increased by deep ploughing. Alkali soil reclamation. So gypsum application in upper 15 centimeter soil depth. Nutrient management require 25% more nitrogen because the nutrients are not available to the constant high soil pH. Low infiltration rate, high evaporation lead to secondary salinization. Application of affirming solubility of applied gypsum and hasten the reclamation process. Using green manure crop like suspenia for reclamation of alkali soil. Kernel grass, root grass have been found tolerant to alkali soil. Then plow the soil at optimum soil moisture design. Replacement of excess exchangeable sodium. So in saline sodic or sodic soil, leaching directly with water low in salt may lead to further increase percent sodium saturation, thereby increasing concentration hydroxyl ion in the soil solution. In such situation, the toxic sodium carbonate and bicarbonate are first converted to sodium sulfate by treating the soil with heavy application of gypsum. So sodium clay, so when we are at the sodium like gypsum calcium sulfate, then sodium is replaced by the calcium, so soil becomes calcium clay. The resulting sodium sulfate is then leach out with the root zone with the irrigation water. So when we are apply the gypsum in sodic soil, then leaching is required. Otherwise, there is no benefit of the gypsum. The use of sulfur also reduces the intense alkalinity in sodic soil. During the process of sulfur oxidation to sulfate, there is production of hydrogen ion which lead to lower in the pH of the soil. So sulfur help in reducing the soil pH. Then reclamation of the sodic soil, gypsum improve the structure stability of dispersed crop quite quickly. Figure in 1 to show that in the right side there is an application of the 5-ton gypsum. So you can see the growth of the wheat crop. Here the gypsum is not applied. So here you can see the white crust and poor growth of the wheat crop. Whereas on the right side, the better growth of the wheat crop is the application of the 5-ton gypsum per hectare. Organic matter. The organic matter improves and prevents deterioration of physical condition of the soil by its interaction with the inorganic cation exchange material. So in a problematic soil, either saline or alkali soil, we should have to add more organic matter. It helps in improvement of the soil. A alternative for irrigation scapping of top and ridge and furrow method of cowpea cultivation at Odisha. So a scapping of the topsoil is an alternate for irrigation method in cotton crop. Then cropping pattern. So a rice-based cropping system are proved to be beneficial over sorghum-based cropping system. The following crop have been recommended for cultivation during the post-reclamation phase. So cropping sequence is recommended for alkali soil. So here the soil pH 0 to 15 centimeter, 9.2 to 9.3. Then we have to grow the year after reclamation cotton, sorghum, pulse millet in Rabi, mustard, or rapeseed. Then the soil pH 8.9 to 9, and a year after 5 to 8, then sugarcane or tur, groundnut, soybean. Then in Rabi season, barsim, sunflower, grams, safflower, lentil, and pea. Then soil pH 8.5 to 8.8, year after 8 to 10, all crops including vegetable, flower. Fertilizer management. Fertility. If salinity is a problem, avoid fertilizer containing chloride. So don't apply potassium chloride in a alkali soil. Replace muriate of potash, potassium chloride with sulfate of potash and use NPK fertilizer containing sulfate of potash. So don't use muriate of potash or potassium chloride, but we should have to use sulfate of potash. Then nutrient management, nitrogen application of ammonium sulfate is better than urea, calcium ammonium nitrate. So it helps in reducing the soil pH. Phosphorus, a high pH availability of phosphorus is more and hence no response to apply fertilizer in early phase application. But gradually phosphorus availability decreases. Potassium uptake decreased due to high sodium and deficiency of calcium in alkali soil. Then the green danger crop. So you can grow the danger crop in a problematic soil or saline alkali soil, and plantation of Prosa julifera in highly sodic soil, Saraswati range forest area. Also, you can grow the kernel grass, road grass have been found tolerant to alkali soil. Then selection of crop. Crop vary widely in their tolerance to salinity. Relative crop tolerance for exchangeable sodium is given in table 1. Table 3, selection of tolerant varieties within crop is essential for good production and economic return for saline soil. So when there is a range of exchangeable sodium percentage, then you have to grow crop. Suppose 10 to 15, then you have to grow safflower, black gram, peas, lentils, and peas. Suppose ESP is 30 to 50, then you have to grow wheat, rice, sunflower, bursin, and blue penny. And when there is a high 69 to 70 ESP, then you have to grow rice and kernel grass. So as per the range of the ESP, we should have to choose the crops in the field to achieve the higher crop production. And crop selection, crop management. So rice is preferred in alkaline sodic soil as it can grow well submerged. Barley is the most salt tolerant crop, cereal crop. In North India, the farmers of the Punjab and UP, they grow the barley because it is a salt tolerant crop. Agroforestry system like silviculture, silvipasture, etc. can improve soil physical and chemical properties along with additional return on long-term basis. So on long-term basis, we can improve the alkali soil. So here you can see the salt tolerant rice variety we can grow. Then Bhalia wheat, it is grown in Bhalia Vista in Bhalia area of the Gujarat, and it is exported. The quality is excellent. Then barley, then cotton crop grown in the Saurashtra area of the Gujarat. So agroforestry, a promising alternative in salt affected soil. So you can see here the crops, rice crop and agroforestry. So irrigation management. So proportionate mixing of good quality, if available water with breakage water, then using it for irrigation reduce the effect of salinity. Alternate for irrigation favors plant growth more than flooding. So in cotton crop, farmers are using the alternate for irrigation method. Then drip irrigation, farmers are using in cotton, and government of India gives you subsidy 50 to 70% for groundnut farming, sprinkler irrigation. So recently farmers have started the sprinkler irrigation in groundnut crop. Then drip irrigation, cotton I told. So drip irrigation can reduce the effect of salinity by maintaining considerable moist soil around plant roots and providing continuous leaching of salt along the edge of wetland. Monitoring salinity level. If you have regular irrigation water salinity problem, you should have a meter to monitor salinity level. Small handheld meters are readily available at reasonable prices. So thank you very much. And if you have liked my YouTube, then please subscribe